Alright guys, so the next thing we're going to be looking at is 7.5 trapezoids and kites. So basically we're just going to be looking at the diagonals and the angles within these and how we can solve problems by looking just at those pieces of information. So the first thing we're going to look at is your vocab on your paper, on your notes. And on the vocabulary definition it says, the base angles are two angles that share the base of the trapezoid. So for instance, if I have a trapezoid here, so let's go ahead and say I have a trapezoid that looks like this. I know that there's two different bases. There's a base 1 at top and a base 2 on bottom, pretty much. This is known as a leg and this is known as a leg. So what's going to happen here is these two angles are going to be bases with each other. So you could call this base 1 and base 1. And then these two angles down here are going to be known as bases as well. So these two bases right here go together. So you could call these base angles. And these two bases here go together as well as base angles as well. So these are known as your base angles of your trapezoid. Alright, the first theorem that we're going to look at has to deal with just trapezoids. And we're going to be looking at theorem 7-15. And what it states on your notes is, the base angles of an isosceles trapezoid are congruent. So for instance, if we have a trapezoid here, I know that these two lines right here are going to be parallel to each other. And then if these two lines right here are congruent to each other, then that makes this an isosceles trapezoid. And when that happens, it tells me all of my base angles are going to be congruent to each other. So I told you earlier, this is known as base 1 up here, and this is known as base 2 down here. So the ones that share the angles right here on base 1, these two are going to be congruent. And then these two angles that share base 2, these two angles are going to be congruent to each other. So again, the base angles of an isosceles trapezoid are congruent. The next one we're going to look at is theorem 7-16, which still deals with trapezoids. And what this theorem states is, the diagonals of an isosceles trapezoid are congruent. So again, just like 7-15, we're dealing with an isosceles trapezoid. So these two lines are parallel to each other. These two lines are congruent to each other, which makes it an isosceles trapezoid. And if I was to draw diagonals from this angle down to this angle, and this angle down to this angle, let's go and name this. This is A, this is B, this is C, and this is D. If I have two diagonals of an isosceles trapezoid, then those diagonals are going to be congruent. So line AC here would then be congruent to line DB here. So it would be congruent to line DB. So the two diagonals of this are going to be congruent to each other. Okay, and the last theorem that we're going to talk about in your notes is going to be dealing with a kite. And what 7-17 states is the diagonals of a kite are perpendicular to each other. So for instance, if I had a kite here, so these two lines are going to be congruent, and down here, these two lines are going to be congruent. This is known as a kite. So if I was given the diagonals of both of these, so if I drew a line from here to here, and then I drew a line from here to here, the diagonals of a kite are going to be perpendicular, meaning it makes 90-degree angles all the way around. They're going to meet at exactly 90 degrees. So again, the diagonals of a kite meet at a 90-degree angle, which that means they are perpendicular. I'm going to take everything we've talked about and let's go and look at example number 1. So right now we have a trapezoid here, and on example number 1 it says WXYZ is an isosceles trapezoid. So what we know again about an isosceles trapezoid is these top two lines are going to be parallel and these two lines are going to be congruent to each other. So with this being said, we know that all the base angles of an isosceles trapezoid are going to be congruent. So we know X and Y are going to be congruent, and W and Z are going to be congruent to each other here. Okay? So the information it gives us on example 1 is the measurement of X is going to be 156 degrees. So automatically, by knowing that our base angles are congruent, I know that angle Y is going to be using the same base as X here, so it is going to be 156 degrees as well. Okay? So now I know these two angles are going to be supplementary. They're going to add up to 180 degrees. So right now 180 minus 156 is going to give you 24 degrees. So angle W is going to be 24 degrees. I know angle W, I know angle Z are going to be congruent to each other because I know the base angles of an isosceles trapezoid are congruent. So these two angles are going to be congruent. So this is going to be 24 degrees as well. So ladies and gentlemen, those are all the angles of your isosceles trapezoid. So the next one we're going to talk about is example number 2. And right here we have a kite. And it looks like on our kite we have two diagonals going across. So I know if I have a kite, I know that these two adjacent sides are going to be congruent. And these two sides are going to be congruent. So what's going to happen inside these kite, from our theorem a while ago, the diagonals of a kite are going to be perpendicular. So that means it's going to be 90 degrees right here all the way around. So automatically I know angle 2 here is going to be 90 degrees. Okay? And now right here to find angle 3, I know that this guy right here is 90 degrees. So 90 plus 72 is going to equal 162. And then all the angles of a triangle add up to 180. So 180 minus 162 is going to give me 18. So angle 3 is going to be 18 degrees. So I know that since these two lines are congruent, that this line right here is being shared with both of those. So this is going to be a congruent side as well. So right now I'm going to have two congruent triangles right here. So angle 72 is going to be the same thing as angle 1. So angle 1 is going to be 72 degrees. Okay? And that's how you use the diagonals of a kite to find missing angles. Lastly, we're going to kind of do some examples that were the same as example 1 and 2, but I'm going to combine these together for example 3 and example 4. So on example 3 it says, in the following isosceles trapezoid, angle S is going to be 70 degrees. We need to find the measurements of P, Q, and R, which this is going to be an isosceles trapezoid, so we know these two legs are congruent and these two legs are parallel. So we know in isosceles trapezoid the base angles are going to be congruent. So S and R share the same base, so angle R is also going to be 70 degrees. I know that angle R and angle Q are consecutive angles, meaning they're going to add up to 180 degrees. So right now, if this is 70, 180 minus 70 is going to equal 110. So angle Q is going to equal 110 degrees. And then I also know in isosceles trapezoid that the base angles are going to be congruent. So P and Q share the same base. So P is also going to be 110 degrees. So that's how you find the missing angles of your isosceles trapezoid here. Now over here in example number 4, we are given another kite. The reason I know it's a kite is because these two adjacent sides are congruent, and these two adjacent sides are congruent, and opposite sides are not. So that makes it a kite. And we know whenever I have diagonals of a kite, they are going to form a perpendicular angle, meaning it's going to be 90 degrees. So right now, angle 1, this is going to be 90 degrees automatically because that's going to help me. Okay? I know that whenever I have a diagonal here, it's going to form two congruent triangles here. So angle 46 and angle 2 are in the same place technically. So those are going to be congruent. So this is 46. So I know this angle is 90 degrees because it's the two diagonals meeting at 90. I know angle 2 is 46. So if I do 90 plus 46, that's going to give me 136. And I know all the angles of a triangle add up to 180. So I'm going to do 180 minus 36, and that 180 minus 136, and that should give me 44 degrees. So angle 3 is going to be 44 degrees because those angles add up to 180 degrees. Okay?